Okay. Okay. So this is me again. Um, Software engineering mentor. I'm also the co-lead for Google Developer Group. I'm stuck on trends in the UK, and I also contribute to open source when I can. Okay. So we're just going to be discussing advanced TDD practices today. I think for the other sessions, I think we spoke about the introduction to test-driven development, the advantages. Then we looked into front-end testing, some of the tools and how to write front-end test using the TDD approach. And I think last week was backend, where we like, I think it was live coding last week, yeah, where we like wrote some code and then wrote some tests using Express and Supertest as our test runner. So this week we'll just discuss advanced TDD practices. Right. So I'll just do a recap of the past few weeks, right? So why would you want to test? Why do you want to add tests to your code? Um, One, it's like it gives you like a safety nest. That's the right word. Yeah, safety nest, like some form of confidence in what you've done. Because you've tested. So what is TDD basically? Let me start with that. Basically writing tests for your code, right? Testing your code. Just the way user would interact with your code, right? So that's what TDD is all about. Um, Three approach. It goes with like three approach, or what do we call it now? You write your test, which is red, green, and refactor. So you write your test, write your code, and then you refactor, right? So at the point of refactoring, your test is already passing, so you are sure that, oh, if my test fails, that means I've broken my code, right? I've written something that's not meant to be there. So we spoke at the advantage, which is like safety net. At the point of refactoring, your test is already passing, so you can easily refactor, right, and easily add new features on top of your existing code, and you're sure that, oh, I'm not breaking anything. As long as my test is passing, as long as you're writing good test. I mean, you can write bad test, right? So as long as you're writing good test and you can easily refactor, add new features, is also a form of documentation, right? Because I just reading your test, I should know or understand what is going on in your application, right? Or in your file, or your routes, or your components, or your page. So right. Um, some form of tests or some examples of tests, right? I think we spoke about three main ones, even though they're like other ones, right? We spoke about unit tests, which is like testing a unit, a piece of code, right, in isolation. So I have a function that doesn't have any external dependency. That's like unit test in isolation, complete isolation, right? Also integration test, where you bring multiple components, multiple functions, right, together to test that they would behave if it would give the expected outcome, right? Then we also spoke about end-to-end tests, which is like testing the entire workflow, which is more complex. Say I have like a login page, I want to test end-to-end. Just the way the user would behave, click on the button, fill in your form, your email, your password, or username and password, or Google authentication, social, anyone. And then you are redirected to your dashboard page and you see what you're meant to see. So end-to-end also shows up like in a browser mode where it launches and then you see the clicking and everything. So like it's more complex. It's gives you more confidence in your code, right? Because it's like real user behavior, how users will interact with your code in the browser. So I spoke about those three, even though there are like some other ones like acceptance, smoke test, which is like smoke test is basically running the most important test in your code. So you have like a lot of tests in your code, right? But it takes time to run those tests. And then what you just want to do every time you make a push is test the most important features. Are they working? Oh yeah, they're working. Then I can release the application, right? So it's not common. I mean, some people use it. I mean, I use it at times. If it's like a play project or just a fun project, nothing too serious, I just write some smoke test. If I don't want to run everything or write tests for every part of the application, it's just like right, the most important part. And then once I push, my CI/CD picks it up and once the most important features are working, I know, okay, if the less important ones are breaking, okay, it's fine. The ones people use the most, that it's like working. So, I mean, in real production applications, large applications, you probably wouldn't want to do that. You probably want to write tests for everything and make sure everything works well. So we spoke about that. Also spoke about some tools, right? So for front end, using React as an example, as our framework, tools that you would use just for your test runner, or VTest, which is like more recent, it's faster than just, but they have the same syntax, right? So as a test runner, we spoke about using Cypress or Playwright for writing your end-to-end test. Spoke about using React testing library for your unit test, right? So to test your components, and also integration test to test how your components will react to each other. On the back end, we use them super test as the test runner, right? No, we use jest as a test runner, and we use super test for assertions, right? While on the front end, it was React testing library as the assertion library and jest as a test runner. On the back end, we used super test for asserting that we're supposed to get our routes, our APIs should return the correct response. And we use jest as our test runner. Or how else did we discuss? I think we also wrote some code, unit tests, and some integration tests. If you check the old videos, you should see some of that. Also going to like try as much as possible over the weekend to finish up the GitHub repository. So I could also release that, and some resources also that help me. And I think with the others also. We also spoke about some of the things you should test and some of the things you shouldn't test. For instance, I'm using like Bootstrap, right? Or Tailwind or jQuery or a framework or a library, a third-party package, for instance. I shouldn't be testing that third-party package, right? Say I'm using the modal, right? All I'm concerned about, or all I should be testing is I click on the button to open the modal and the modal is opened, right? That's like user behavior, what the user the way the user would use it. But trying to test the inner workings of the package that you are using, like say for instance, you click on the button and you're trying to check that the script that the package is using is being triggered. That's like a no-no. Like, why do you want to do that? You should test, write your test in a way it would replicate or mirror how a real user will use the application. So that's like the most important thing you need to test. Also, what else did we discuss? I think that's basically so far of discussed. So today we'll be talking about advanced TDD practices. So let's get started. So one is like test doubles. So what are test doubles? Like basically, so like object or functions used in testing that as replacement for root dependencies, allowing developers to isolate code and control its environment for more reliable and efficient testing. Last week I gave an example, right? While I was writing the test, actually like a piece of code where when you like in our applications, right? When the user registers, we normally send out emails, right? So or you have like Slack bots or Slack notifications when something happens in your application. You don't necessarily want to do that in your test. You don't necessarily want every time you that particular test runs, you send an email out or you send a Slack notification out, or your front-end application, right? You connect to an API source, right? You don't always want when your APIs, when you're running your test, you don't want your test to like interact with the real API. Like one is going to make it slow. Two, what if the API, what if, okay, so for instance, I'm doing like a get and I'm like coding an ID. What if that ID is deleted? Your test will fail, right? but it doesn't mean your test is wrong. It's just that that particular ID you had coded is no longer in the database, or you're checking that, oh, I clicked on this button and a resource or a user or something is deleted in the database, right? That's fine, right? What if I go back the next time and that ID is no longer there? Or first time I run the code, that particular resource is deleted. Next time I try to run my test, my test will fail, right? But there's nothing wrong with my test. There's nothing wrong with my code. It's just that I'm mutating the original database, right? So you don't necessarily want to do that. So probably you will use like a test double, right? So you isolate your code from external dependencies. You control the behavior of dependencies during test. And it also makes your test faster because you don't have to make actual API calls or interact with the database, right? You create like a stub or a spy, mock, fake, or dummy. I mean, I'm going to be talking about stub, spy, and mock. It's like the three most useful ones I use from time to time, or almost every time when I'm writing a test or test suits, right? So stub, spy, and mock. I mean, I've gone over the advantages of these three, and we're just going to go over each of them one by one. I mean, if you have any question at any point in time, you could just go ahead and ask. It's fine. So what is a stub? A stub is a function that returns a fixed result. It does not track the usage. You'd see that in action. It is used to simulate specific return values to control the flow of the test. For one of the examples that I gave, so look at this right now. Look at this code. This is getting a user using a particular ID from an external resource, a URL using exist, right? So I have this particular function, and on the right I have the test, right? So if you take a look at the code, it's straightforward, it's simple API call. But on the right hand side, I'm working Axios, right? And I'm creating a stub, which is I'm saying, okay, mock user. I'm creating a constant set that's called mock user, and I'm returning like a resemblance of what the response from the actual API would look like, right? So that's we call it like a fixture, right? It's like a resemblance of what the actual API would return. And then I'm making the API call by saying, okay, mock exers.get, this is the result value. This is what I want the value to be, right? Because this is what the normal API returns response of data. That's what I'm assessing. And on the right, I'm saying, okay, instead of making the API call, create a stub for me, right? Return this response instead. So anytime I call this function, get user, I'm mocking Axios, right? And I'm returning a stopped response, which is what I've created, the ID and name. So when I run my test, I'm saying, oh, the response would actually be mock user, which is what it should be. Then I can actually control again and say, okay, when the API fails, what should happen? It should return an error, right? I can easily just mock it again and just return the error and just write my test. If I was calling the actual API, it will be slow. What would happen if this ID that I'm coding or that the user passes in does not exist in the database? The test would fail. But my code is fine. My function is fine. My test is fine. It's just this resource doesn't exist in the database, right? So that's why you want to create a stub, just so you don't call an external resource, slow down your test, and all of that. So I think I have a code here. So I have an example of stop the test. Same thing, just like a little more stuff I'm going to explain. So same thing, we have this get user, we have these simple exhaust call. I'm returning these, and then once there's an error, try catch, which is not here, and just function change. And this is it. I'm trying to fetch the user, right? I'm going to run it right now. Stop the test, correct. So take a look at the time, all right? 4 milliseconds. So if I'm going to take out this right now. All right. I'm going to take out these the mocks, right? I'm going to make sure it like uses the actual API to make the API call, and then we're going to compare how long is it to take, and just run some simulations. I don't need the smoke response. I don't need to check if it has been called, and I can easily just keep this. So I just want to ascertain that, okay, the response I'm getting is equal to this when I call this API. I'm going to run it. I don't know if this ID exists in the database, right? I'm not sure. I don't know, like in their database. I don't know if it exists. So I'm just going to call this and see what happens. Yeah, it fails because this the error I'm returning. So if I console.log the error to check what actual error is from them, then it would show me. Right. I just do error dots. So let's see what the picture is. Start error. Run and test again. Let me see what it looks like. Okay, yeah. So this is the message here. It does exist. Request failed with status code 404. That means this resource I'm trying to access doesn't exist. That means they don't have a user with the ID of 100. I mean, my code looks fine, right? I'm just connecting to their database, but then they don't have this user with the ID of 100. So my test would fail. I will run my test will fail. I'll be like, oh, but everything looks fine. What's happening? But actually, in actual sense, I'm trying to get the resource that doesn't exist. Probably existed before when you wrote this test, but then later on it was deleted. And then I'm running my test. My test will fail. Nothing is wrong with my code. Nothing has changed, but my test is failing, which is bad. We don't want that happening. That's why I would normally use stubs to just we'll get what the API is returning for a success response. So there's a validation. If you want to test like validation, you get what happens when validation fails. This is actual error. If there's a network error, this is actual error, and then you create like stubs, custom responses, mirroring what the actual response looks like. So you don't have to make API calls, and then you just stop the API and just create a replica of what the response is and just create your mock. So you don't have to make actual API calls. Okay, so I'm going to make this test pass. I know there's always the idea of one. I know. So I'm just going to run the tests and it's still going to fail. Right? So the actual API returns more data, right? I didn't mirror mine to what the actual API is. I mean, I could, but I didn't because I just. But I mean, the most important thing I wanted to show also is the time. When I created like the mock, it was like I think 2 or something seconds. Yeah, it was just 4. But then if you make the actual API call, it goes up to 194, right? And it's failing just because my mock is not equal to what the actual API is, right? So if I wanted to create a good mock, it would be mirrored to what API would return, actual API would return. So my mock user, this would be equal to all of these things, right? And then my test will pass. But then the time it takes to just, because it's making the actual API call, right? So the time it takes to just go and make, like, this is just one test. If you have like 10, 20, 30, then how would you do that? Also, when you want to test when an error occurs, right? Say there's an error, I can easily control that by just doing a mock and returning a custom error message or whatever, and then it passes, everything is fine. In my components, when there's an error, I can easily just mock this and just, oh, okay, my error message is shown, something like that. So in real world applications, you would always use stub. You would always mock actual APIs and return custom response that mirror what the actual API would return. So that's like stub for you. So stub is I intercept and return a custom response that looks like what the actual response is. I mean, might not necessarily be for APIs alone. If you use dependency injection, maybe you're injecting your database, you could mock your database. Also, just creating a replica of what the actual response would look like. That's stub. Okay. Any questions? Just gonna bring up this back. Okay, so I think I explained this. Okay, mock. So mocks are like stubs, right? They're quite similar. I mean, there's a thin line between mock and stub. A mock is just another stub, but with something else. So you also check expectations, right? So I'm going to, this is right here now. This is where my stop, yeah, stop. I'm mocking my Axios get request on Axios. I'm saying, oh, this is the result value. This right here is stop. So once you now start checking that, oh, what I mocked, right, which is like Axios.get should be called, has been called times one. How many times API has been called? That means you're sure that you called it once and it's been called once, like it's not being called twice or three times or whatever. You can should have been called. You have to check how many times you should do these the different assertions that you can do. Right. But once you start checking your mocks, like I'm mocking this Axios model right here, right? Once I start writing assertions on a module that I have mocked, that makes it a mock. I mean, the line is thin, like I understand why they would like make it sound like that. But I mean, that's what it is. This is where my stopped right here. These are just normal assertions on my function. But once you start making assertions on what you mock, this is mock Axios. I'm checking that, oh, it should have been called times one. I started to check that, oh, A has been called with, that means my Axios or get has been called with, which is what I mocked, the module I mocked, has been called with the correct URL right here. Then this is like mocks, right? So, I mean, it's just like stub, it's like a combination of stub and then expectations on the usage where you're checking, writing assertions on your mocked module. That's what we call mock. I mean, it's a plural line meaning that. Okay, spy. Okay, so spy is with, there's a bit of difference. It's similar, right? They do like similar things, but there's like a bit of difference and there. Spy is like it's with mocks, right? You are mocking a module like this. I'm mocking a module. Axios is a module, a third-party module. But with stub, you are so okay. Yeah, with spy, with mock rather, you are completely changing the actual implementation. That means that once you do a mock, the actual implementation of that code is taken away. You have to add your own custom implementation, right? That's another thing with mock. So if I do like just a mock and then I come here, if I don't do a get because I need to do like a mock result value on top of this because now I have mocked just now that I've used just mock Axios, I've completely replaced the actual Axios with a mock. If that makes sense. So I need to now put like the response, or what the function should actually do. I need to by myself write it out, right? I'll give another example, even though it exists. I think I have another example here with, I think it's spy. Yeah, okay. I have this here. Okay, you can do this. So I'm just going to explain spy, and I'm going to show a bit of difference between this. So spy is I have a video function here, right? And then I want to spy on the play function. I want to make sure that probably when something happens, the play function is called, right? I want the actual implementation of play to stay in place. I don't want to replace it with my own custom implementation. I just want to spy on it, right, on a function. And maybe when an action occurs, I want to check, oh, my play is now triggered and the return value is what I expect it to be. So this is like spy. So I import the module, which is like video. It could be anything you want to, but it has to be a method or an object, and then you now spy on a method on it. It has to be like an object or a class, then you now, or a component, you now spy on like a method on it. So this is the video object right here. So this is like export from video. This is an object that has like a method inside, right? So I want to spy on this play method, right? I'm not changing the implementation. I'm just spying on it. Maybe when they click of a button or when the play is called, I want to check that, oh, it's been called and the response is true. I mean, this is just trivial. This is like very simple. It could be like complex interactions, complex things that you are doing there. And at the end of the day, maybe different if checks. And then at the end of the day, there's a particular response that should be returned, right? So it could be something complex. But you want to do a spy. You want to check that, oh, when this play or this function is being called, the response is what it should be. I'm not changing the underlying implementation. With mocks, we are completely changing the underlying implementation. You need to now return a custom response, right? But with spy, you have the ability, you can leave the underlying implementation and just spy on the function, meaning you just say, oh, when this function is being called, this is what the response should be, and it is correct. You're not returning the custom response if you don't want to. So so this is like I'm spying on play method, which is on this video object. I'm spying on it. I'm spying on video actual function. So this is it. So example, same example that is in Jest documentation. I just reused it because it made sense, right? So I have this spy. I'm spying on video objects. Could be a service where you have like login method on the service, on the user service. You have like login method. You're spying on it and you're checking that, oh, when the user logs in or when they like put in correct credentials, they can access. The token is created or they are redirected, whatever you want to do. You're spying on the actual function and the actual implementation stays in place. You're not changing it. It stays in place. If you don't want to, it stays in place, right? So probably this is what explaining better. So I do this, I spy on video, which is the object. There's a play function on it, right? Which is this right here. This is the object. This is the function on it, play. So this is what I want to spy on. Literally spy, like spies in movies or reward. And then when I call my video.play, right, I call the function, displaying is Boolean because that is what it returns true. I'm checking that my spy is being called, which is my play function. It's being called, and I'm checking that the response is true. If you notice, I'm not returning any custom response on this. I'm just running the function and I'm checking that, oh, the value is true. So that's the difference between spy and mock. With mock, you have to return a custom response. With spy, the underlying function is still there. It functions the way it should be, and you can just check that the value should be correct, right? So, but then spy has an advantage where you can override the underlying implementation. I can change what the response looks like if I want to. If I don't pass in any, if I don't want to mock or change what the response is, it's fine. Spy would work, no issues, right? Because I'm spying on something. The underlying implementation is fine. It will return the actual response. But I can also, if I wish to, if I want to, change what the response looks like after spying on it. I can change what the response looks like. Something like this. I'm now doing a mock implementation. I'm returning false instead of true. So normally when the function runs, come here, it returns true, but I don't want to probably for whatever thing I want to do. I want to change it to false. So I do a different assertion. I can easily do a mock implementation on that, change what the response looks like and return false. And once I call my function play, the response is now false, right? So that's like, I don't know if I was able to explain it well, but I mean, that's like the major difference in Spy and mock. And then there's some other differences with mock. You have to mock everything as a module. So with mock, I'm mocking this module, which is like dot video. So I'm mocking everything like this, boom, everything. And then on that, I'm now saying, okay, there's a video object in here that has a play function. I want to return this custom response. But with Spy, I'm just spying on video and then I'm calling play. But with mock, I'm spying on an entire module and then I have to construct what I want to be there. Right. So if let's say for instance, do this right here, I'm going to remove the Spy. I'm going to just do this. If I don't add this, let's just do maybe an object. Okay, that's fine. Just dot function. Okay, so I'm returning like a function that does nothing, that doesn't return anything, right? I'm working the module. I'm doing this. I don't want to return like a custom response, or a custom implementation, which if you want to use mock, once you mock an entire module, you have to add like a custom implementation on top of it for it to work very well. I'm not doing that right now, right? So I'm going to say, blah, 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 I'm going to call this. I'm going to do this. I'm going to remove this. I'm going to remove this. Displaying is this. Then expect this lane to be false. This ordinarily should fail because I'm just mocking this and then I'm just returning a just function, and displaying is not anything like so just on this, and that is pi. Yes, I can say pi. Yeah, yes. Yeah. So there's no play, right? So because I mock this entire module and I'm returning like a just, I can return an object there. So it's just a function. Same thing. Because I've mocked the module, now it's like a custom implementation, like all over again. There's no play implementation like on top of this video module that I've mocked. So that's like a major difference. Mock is changing everything. Like you mock a module, you now have to add the custom implementation. So if I come here, if I open this up into the, yeah, it's not hard. Okay, return video, play, blah, blah, blah. Just the same way this was structured, right? So I have to now construct this and run it. Yeah. So because I returned true, now there's a play functionality on top of video. It's not saying, oh, this expected true, but return because I returned. Then I can always like do this and all of that. I'll show you an example of when mock is like extremely useful. Let me see. When you want to mock a module, I mean, you could mock something. Say you have a component and you import your component in maybe much more bigger component, and you want to write tests, and then the smaller component is giving you issues in your test. I've seen some people just mock an entire component and just return a div. That's like a wrong test. Like just the mock will give you that, or Vit the mock will give you that, but that's entirely wrong because you're not testing the interaction. You're just creating a mock and just returning like a div or something that is wrong, and then, oh, my test is passing, I'm happy, but then that's wrong. But you need to be careful when you mock a module. You need to make sure it mirrors actual implementation or not. But you need to be careful of what you are returning, basically, right? Or else your test will just be wrong. You can give something, an example. Also, you can mock node modules. Like if you install a package, let's say I installed Slack bot, or I install Node Mailer, which is for sending email in Node.js, or an SMS like Twilio, right? But when I'm running my test, I don't want to send SMS. I don't want to send emails. I mean, I'll be burning money. It's how it's just a test. I could easily mock the Twilio package. I can easily mock Node Mailer, so I can return a custom response, and my emails are not actually being sent. So I'm just going to give an example with Node Mailer right here. So you can do like manual mock, or you can do automatic mock. This is like this one here is like automatic mock. I find it. So in this scenario, I'm mocking Node Mailer and I'm mocking Slack. If you notice, right, NodeMailer.ts Slack web API index. Again, something to get to. It has to follow the same convention with how you imported it. So that's like, let me see. Exactly. So if you take a look at this, I'm importing web clients from Slack / web API. So it's just like me sending a message to Slack. So when something happens, I want to send a message to Slack. That's what like this is doing. So in my test, I don't want that to happen. Like, it's fine. Just log something in the console for me to know that Slack was triggered. It's fine. I want to intercept. Yeah, that's correct. I want to intercept, create like an interception between my test and the Slack bot to say, oh, okay, when Slack is being fired, instead of doing what Slack would actually do, replace web clients, send message. New client web. Yeah, just chat.post message. Replace this whole implementation with my own custom implementation, because I don't want Slack to be triggered. That's a valid use case, right? For creating like a manual mock. So I'm just going to look at the import part. That's why so if you talk about the package, you need to add Slack / web API. Slack is a folder, web API is a path. This is the folder, then this is the file. So a Slack is the folder / web API is the firm. This is the folder, this is the file. So same thing you have to do here. A Slack web API, then I created like an index, which is like factory, whatever. And then what do I want? What am I importing? I don't want this one. Let me just search and this. What am I importing? Web client. Awesome. Web client. Web client is a service, right? So sorry, it's a class because of the new keyword. So this is definitely a class. Create that mock implementation. What am I calling on the class? Chat. The post message. Chat. That's the like the object post message. is the function. Then I'm mocking in that. Okay. Instead of calling, actually calling Slack, anytime I'm using this service and Slack has been triggered, and I'm running post message, instead of actually sending a message, intercept it and just return okay, true, right? So like doing that. Same thing for Node Mailer. On Node Mailer, I'm using what's it called now? Send mail, which is like the function that I'm actually calling. I'm saying, oh, okay, just mark this return value for me and don't send emails. If it was Twilio, I'll just check how Twilio was being imported, track it like that, create it here in mocks, and just put everything on the functions there, and just create a custom response. So instead of calling the actual API, you create like a stub. No, not a stub. No. Instead of calling the actual third-party package or calling your function, or you create like a mock, you replace the old implementation with a custom implementation. But with Spy, I'll just spy on send mail as the method, right? And then my emails will actually still go through because I'm not mocking the implementation. If I don't want to, I'll just spy on it, right? And then when the actual thing like happens, I'll just check, oh, was send mail called? Yes, just like what we're doing here. Right here. Let's close it up. Just like we're doing with the spy here, right here. So I created a spy for, I'm going to take it out. Yeah, so I'm creating a spy just like I did here. Created a spy on the video object, and the function I want to work with is play. So if I have another function that says pause, I put this, and I'm saying return false. I can also spy on this and say, you can simply spy. So I'm spying on the function. The actual implementation is still there. It's not changed. I'm not overriding it. I just want to check, oh, is it being called? Is it returning the response it's supposed to return? Play spy. But with mock, you have to change everything. You have to construct everything yourself because you are overriding what is there, like basically. So I can see play spy is playing, play spy is having called this. You can also say boss spy. Because we just spy and I'm spying on what objects, I'm spying on videos, objects, what method I'm not spying on this time around. I'm spying on pause, not play. So I can just say, so having called, then I can say it's pause equals to video.pause, which is the function. Yes, it has to be const. Then I can say, oh, okay. For spy to having called, for spy to be false, for spy should be called once. I can add as many assertions as I want. And okay, take it out. And when I run my test, everything works. I'm not changing implementation. I'm just spying on it. And then when I call the function, I'm checking, oh, was it being called? Yes. Is it return the value I wanted to return? Yes. Oh, okay, everything is fine. So that's like a major difference in spy and mock. With mock, you're changing everything. You're returning the custom response. If you mock a module, you're returning like a custom module, entirely custom, different module. You can have like a user service. You can mock your user service. Say, you have like 5 functions on your user service. By the time you mock it, you can return 2 functions or you can return 3 functions, the ones you need in your test, and just return like a custom response, and everything is fine. Custom components if you have the context of a front-end application. And I mean, so you have to be really careful when you mock, because you can just write wrong text and just mock, and then you just, oh, it's giving me issues. Why don't I mock and just return what I wanted to return and just write my text, and then everything is fine? So you have to be really careful when you're doing that. I mean, it has its own very good use cases, right? Right. Like the instance I gave, I don't send Slack messages. It's a test. Every time I don't want to, like, I don't want to send emails. I don't want to send SMS. It's test. Like, just be wasting money. So it has its use cases, but you have to be really careful when you do that. Spy is much more preferred because you keep the actual implementation in place. So just spying that it was called, um, the response is what it should be, and all of that. So, house spy and okay, I move to first. Okay, so I think I already like spoke about the differences and okay, so between stub, mock, and spy. So we saw how I was mocking Ixios, and I was like mocking Ixios.get, and I was returning a custom response, a stub with mock. Mock is like a stub, but then I'm also um checking that, oh, this thing has been called. I'm changing the implementation entirely. That's like mock. Like the way I mock Axios at the top. Then I started using my mock Axios instead of using actual Axios, because I created like a mock Axios, and I started using like a custom Axios, right? Which is like the mock instance. Let me show that right here, which is same here. So I created a mock Axios module. I don't want to use actual Axios module because I don't want the actual API call to be made. So I created like something that looks like that. That's why we have this assertion right here to say, okay, there's a type of this. That's why I'm able to use .get, and then just like, and then I say, okay, this is the value I want you to return. This right here, just the way this is. Return response.data, exactly the way it is. Mock it, don't make the actual API call, return this value to me, and I mean, fine. Okay, control inputs that test interactions, monitor existing code. Spoke about this. The existing code is still in place. I'm just checking, I'm just spying on it. Just like, I mean, literally what spy means. I'm just spying on it. I'm checking that it has been called with the correct value. I can also like go further and say, okay, if I pass in like a parameter, depending on the parameter, this value is returned. I can say, should I pause? Should pause. It's a boolean. I can do if should pause exactly right. I can see on should pause. Thank you. And then if I come to my spy, then this is because the actual implementation is there. I'm not changing the implementation. I'm just spying on it. Okay, when you are called, return this, blah blah blah. So that's optionally, you can also completely change the implementation, change the response, like I did here. I don't know, I took it out. But yeah. I think I can just find it. Yeah, so this. Yeah, so I just not the implementation. So instead of like play to return true by default, I'm changing the response to false. I'm changing the implementation, I'm changing the return value, saying okay, you can optionally do that with spy. But by default, if you don't pass on anything, if you don't mock the implementation, it will just use the actual function and just spy on it, just check on it when that function is called, everything like is being used as it should. So crowd calls, no, because this is just like a stop returning a custom like response, a value, like maybe I call we saw where I created like a mock user object. With mock, yes. With spy, yes. You can check on, you can track the calls, you can check that, oh yeah, okay, your mock was called, your spy was called. I don't know if I go into some of the tools. What are questions? Any questions? No? Okay. So these are some of the tools I use. Right. So for front end, I use Jest as my test runner. Right. So it just helps me run my tests. It's also like mocking, stubbing, snapshot testing. The alternative is VTest, which is more recent. It's newer, is faster actually, because it's built on Vite, which is faster. So yeah, I mean, I still use Jest a lot. I use Vite also, and I use VTest. But for new projects, I basically tend to just go for Vite. It's a new kid on the block. It's faster. More people are adopting it. So yeah, you can check that out. I've added the dogs right there. Also React testing library. That's what you use for your assertions. So you want to get an input in the on an input field on a component. I can just use screen.get by label, right, or get by placeholder text, and just pass that in, and it will just let me grab that if it like does exist. So that's grabbing things, React testing library, right? User behavior, renders components, and some user interactions. Yeah, it does that too. Right? User event or click. You want to click on the button. You want to submit a form. You want to test how a user will interact. You can also use React testing library, like for assertions, basically. So for end-to-end, yeah. And then there's also Enzyme. Enzyme used to be really popular, but I mean, React testing library is like what everybody uses right now, like 90%. I think uses right now. It's way more popular. I mean, also if you check npm downloads, it's like way more than Enzyme. But I mean, Enzyme is also good, but it's less popular. So if you want to learn, I'll just say RTL is what you should learn. React testing libraries, what you should learn. I mean, Jest still has like millions, I think 20 something or something, millions every week downloads, so it's still very relevant. I mean, VTest is just new and just faster. Jest is also very good. That's why here it's been around for a while. So for end-to-end tests, you would use Cypress. I use Cypress, but there's also a new one which is Playwright. It's faster, also, and it has more browsers, multi-browser test. So you would be able to test your code on different browsers to see how it would work. I mean, sometimes you write your code, it will work well on Chrome. You get to Mozilla, it's acting up, or you get to Safari, and it's acting up. I mean, it used to be Internet Explorer then, but I don't know if people still use that browser these days. But yeah, it has more browsers, multi-browser testing. So yeah, I mean, I'm learning Playwright myself, migrating to Playwright. I mean, Cypress does the work, still very good, still very relevant. Yeah. And then for intercepting API calls in a real-world application, this would, if it's a small application, this is fine, where you just mock exels, do this, and do all of these. I mean, it's fine, it works well. But in a real-world application, in much more larger applications, you probably might not want to do this. The go-to tool is MSW. So what MSW does is you just create your handlers, the URLs, the response I'll show an example, I'll show that documentation, the response you want to return. And when the API call is triggered, what MSW would do for you is it would block or intercept the API call, like a network request. It will block it and return your mock. So it's not just for, you might not even use it for just your test alone. You might just power the application with mocks, custom response. Maybe you're waiting for the API, you know what the interface of the response would look like. While you're waiting, you just use MSW, right? and then return a response, and you're fine. When the API comes, you just swap it out, everything works. So maybe you might probably not use Axios or Fetch or mock your Fetch or Axios or whatever tool you're using to make your API call. Like this, like bigger application, you probably would use. Let me show. Yeah, so this is what it looks like. So this is like an API call, right? So you decide this, like put this, and then you just http.get, just put in the URL like this. I mean, it will mix taking dynamic URLs and then you just, oh, this is what the response would be. And that's it. And you set up test or your main.ts or whatever what you want to use it. You just start it like this. And then anytime this actual API is being called like this, it will just do a URL mapping or URL matching. Anytime this is called, it will just intercept the network request and just return this response back to you. It doesn't matter if you use Axios under the hood or if you use Fetch. It will just intercept the network call and just return a custom response to you. So, I mean, I use this every time. It's like my go-to tool, and it's very, very go-to tool for a lot of engineers. If you check the feedback or what people say about it or the downloads, it's Correals, I mean, big names, right? That's what they use. That's what my company uses. That's what a lot of people use. Just intercept API calls. So instead of mocking your Axios manually, you don't even need to do this right here. You just do your assertions after defining your handler, and boom, it would work. It would just intercept it behind the scene. You don't even know what's going. Need to know what's going on. Just do the intersection and just return the custom response to you after you've defined like this. Just so you could just have that one file where you have a lot of handlers, different handlers. I think I have an example. Let me just try and get it up. Here. This is like an old application. This is like an old version of MSW, but let me check. Should be. Yeah. So I just have my handlers for all. So I just have one file. I mean, you can even break it down into different files and concatenate everything together. So I just have one file for all of my URLs. Like, so I just have two URLs there, right? So just have 1, 2, and anywhere this API call, anywhere this URL is being called by whatever clients are using to make an API call, it will just intercept and just return a custom response to you. So it's very useful, very good. So, if you're making API calls, you really should use MSW to intercept your API calls. Very useful. Also for backend, so I use Jest, obviously, as a test runner. Supertest, we used Supertest last week to assert that our APIs are working as it should, and the response are awesome and good, what we expect. If there's an error, our validation should kick in, what's error response or what error code or the body of the response should look like. We check all of that with Supertest, and it's like, I mean, number one go-to for that. Also MSW. So if you are making external API calls, let's say, you probably have an application where, I mean, you speak to other applications, other APIs, other applications through APIs, even the microservice architecture where you have to speak in another service. You don't necessarily want to make the actual API call to call that service. You would create a mock response of what the service will return if it's successful, depending on the scenario, right? And just use it in your application so you save time. Your applications are fast and all that. So you just, like I showed earlier, you just create a handler and put all the URLs there. You can split it up Say you have user service, yeah, user microservice. Say you're on user microservice and you want to call product microservice. You're using like REST API to interact. You just put the URL right in one handler or different handlers and just merge everything together. And by the time you are running your tests, MSW intercepts and just return a custom response that you've defined for you, and that's very useful. That's a powerful tool. Before MSW came, you had to create like your mocks just the way I did in my test. But then, I mean, people are always improving and trying to get things better. So MSW is very good. I mean, there's also knock, which is also good. But I mean, MSW for me does the work. So just go back again. Front end is what the things I use. The ones on the left are like everyday or like number one go-to tool. Then I also added alternatives, which I'm also testing and I'm trying out. Right. So, and then so I don't know if you have questions. I'm also going to drop this document in the channel, so you can also go through if you have questions or you have issues with your test or setting up or whatever issues here. We could definitely just check it out together. Once I'm done with the repo, also would contain like the front end and back end code, and just drop it there. Try to make it as simple and explanatory as much as possible. Yeah, so that's it. I don't know if you have any question. I can take them now.